1, 2, 3. Okay, thank you. So here we go again into the lesson. Okay, your first question here is about this one here, chemical part 5, sub part 2, sub part 4. Okay. The question is about the synthesis of GHH, okay? And it is the reaction between two parts, glutamic acid and cysteine. But I'm going to just take the important part of them. For the glutamic acid, the important part is we have a carbon, okay, at the end that has this condition here. We don't care about the other part. We care only the condition that it has a carboxyl at the end. On the other hand, we have the cysteine, which in one end we have the carbon bonded to the nitrogen. This nitrogen has two hydrogen in it. Okay. And this carbon here, they also have the thio alcohol and some other part that we don't care. We are going to consider only these two reaction centers. We are going to identify the reactive nucleophile and the reactive electrophile of this reaction. Okay. Now, we know that in the end, we're going to have the nitrogen directly bonded to the carbon. So we know in the end, it's going to be this way. Carbon, oxygen, okay. That's going to be the nitrogen. Okay, and that's going to be the hydrogen. And that's going to be the carbon, etc., SH, etc., etc. We don't care. We don't care. Okay. So the key part of this is the bond between the carbon and the nitrogen. So we know we're going to talk about this carbon and this nitrogen. But which one is the electrophile and which one is the nucleophile? Okay, easy. A nucleophile, let's go into the semantics here. Nucleophile, phile means love, okay, is nucleus loving. Nucleus is something that is having the positive charge because it contains the proton. This partially positive in this case. Positive or just partially positive loving parts. Why it loves the positive or positive? Well, it is because it is a negative charge particle. But there is no negative charge particle here. Oh, well, there is, but it is not seen as the first place. What is the negative part here is the lone pair here. The nitrogen has 5 electrons. 3 has been used for the bonding, but 1 is not yet used. That one lone pair of nitrogen is the one who is going to look for the positive charge. Okay, so this is the nucleophile. Electrophile is loving electron. Okay, be it single electron or more common, a pair of electrons. So it's something that is going to look for it. An electron, to be attracted and attracting to an electron, needs to be positively charged. So it will have Okay, it's an object with either positive or partially positive charge. We don't have any positive charge here because we know the formal charge is neutral. But we do have a species, a particle with partially positive charge. Where? Here. The oxygen, because it is the second most electronegative element in the world, they will be partially negative in any bond with any element except fluorine. So it's going to be partially positive. They are going to attract the electron equivalent bond, hence it leaves the carbon here to be partially positive. The partial positive condition of the carbon makes them attracting the electron. So this is the electrophile. And that is how we analyze them. Okay, that's the first question, okay, which asks us to analyze the structure, the reactive nucleophile, and the reactive electrophile. The nucleophile will be the lone pair of the nitrogen, or we can say the nitrogen itself, it's okay. The electrophile is the carbon, which is partially positive charge. That's part A. The part B of the question is, we're going to model here and see the movement of the double bond. I think here to start all over. Okay, I'm going to redraw again the position here. So don't care here, but we have carbon, double bond to oxygen, and we have hydroxyl. And we have the nitrogen, okay, which is connected to the carbon, another carbon, and the thiol alcohol. We don't care. Okay. Then we'll have two hydrogen. And it has the double bond. Oh no, I mean the lone pair of electron. Okay. The movement of the electron pair, right? So the first motion is this. This is the first step. Actually, it's just attraction between the partially negative carbon and the negatively charged lone pair. They're going to go closer. When they are too close, we're going to have them making bond. What happened afterwards? Afterwards, here we're going to see this condition for the intermediate. So we have this carbon, I don't care that. On top, they now have double bond with the oxygen and the OH. At the bottom, we have the nitrogen, which we know has two hydrogen. Okay, no longer does it have any lone pair because the lone pair has been used into the bond, and then the carbon. But I'm not going to. I'm cutting it here. So just nitrogen here. Okay, this is an unstable intermediate. Why? Carbon now has 5 arms and nitrogen has 4. Both of them has exceeded their maximum, the normal condition for stable bonding. Okay. Well, actually, for the carbon, especially for the nitrogen, yes, they can make the 4 bond, but in this case, actually, what they have is a negative covalent bond. No problem. So the carbon here, they need to let go of the bond. Which one? The weakest. Among the 5 bonds of here, these 2 bonds are not equal. Double bond consists of 1 sigma and 1 sigma and 1 pi. The pi bond is not stable, so it's the one who's going to be let go. The 2 electron of the covalent bond now goes into the oxygen. Oxygen will receive the initial electron it invested in the double bond along with the carbon's electron. So afterwards, we're going to have the condition when the oxygen Now they have negatively charged condition. Why? The covalent bond that is given by the carbon contains the carbon's electron along with the original oxygen. So that's the electron of the carbon that's now going to the oxygen's orbit. And the oxygen now has the and okay here. This is where the question ends. Okay. Well, actually, there is some follow-up after this. We know that the hydrogen here is going to be let go, and they're going to react there, making them breaking up the bond, giving back the nitrogen, the lone pair, and the oxygen from negatively charged into hydroxyl. But that is beyond the question. Okay. The question just tell us the movement of the electron. The first, the electron pair from the pi bond. Pi bond is a couple of electrons. So the pi bond become a lone pair of oxygen. I repeat them here. So lone pair, first one, lone pair of nitrogen becoming covalent bond. Covalent bond between carbon to nitrogen. And the second, the covalent bond of carbon to oxygen turned into or changed into the lone pair of the oxygen. That's it. Okay, those are the two steps that we have. The last condition, that's the part B of your questions. Okay. Okay. Now, let's go to the last one about the frontier orbital. Which one is used here? I'm going to erase this again. We're not going to go into the details of the molecular orbital. I think we have them by yourself. Okay, you should be. I think you are okay with the molecular orbital, but we are going to have some simple logic here. The logic is that here, if you are donating electron, you can only do that if you have a surplus of electron. Means you have the lone pair. Okay. The lone pair is the highest electron. The electron you have them here comes from the highest part of the molecular orbital that you have. Donating electron, we see previously, this one is the electrophile. Oh, my bad. Donating electron, you are the nucleophile because you have electron, you want to give it to the nucleus. The nucleophile, they have the electron that you don't have them here, that surplus, because it is on the top one between your molecular orbital. It's going to be the highest orbital, highest occupied orbital. So HO. Nucleophile is the HO. How about the one who's accepting electron? You are accepting because you need electron. It's because you have some vacancy. You're accepting electron because you are positive. This is the electrophile. You love electron. Electron here because you have the vacancy. It is the lowest unoccupied. Lowest unoccupied. Or they call them best vacante, if I'm mistaken. So electrophile is the BV. Okay. That's it. It's very simple. Nucleophile give electron. They have the highest occupied orbital, HO. Electrophile, they love electron because they're vacant. Come, electron, fill me. That's the BV. Back into this. So this one is the electrophile. This is the BV part. And this one here is the one who's going to give it. It's the HO part. That's it. Thank you.